Hello and welcome to my 6 combinational circuits video. This one's going to be on shifters. Um, Shifters are basically just moving, depending on the type of operation you want to run, it's a circuit that can move, say you have a 4 binary number, we can use an example, we can say 1, 1, 0, and say that we want to shift that number to the right 1. So that means that all of the bits in that number, 1, 1, 1, 0, will be shifted to the right. And that'll change obviously the value of that 4-bit number. So if it was 1, 1, 1, 0 and we wanted to shift it to the right 1, well, that would result in 0, 1, 1, 1. And don't be confused, it's not that the 0 from the right end went to the front. It's that the 0 on the right dropped off and a new 0 took its place. And you can have that replacement bit be a 1 or a 0. It's up to you. But that's an example of what something shifting looks like. And then so this one, we have, this is a shifter that can take a 4-bit binary input, and we have a switch that'll allow us to change whether or not we want to shift it from the left, or shift it to the left, or shift it to the right. And so if we have, say, 1, 1, 1, 1, in this example, we are shifting to the right. So it shifts A3 to Q2, A2 to Q1, A1 to A0 or Q0, and then A0 drops off, and it's signified by this shift out bit here. This is saying this is going into this is getting dropped off, and then this new 0 here is getting introduced into the new number, and that's because this circuit will automatically assume that we want that new bit to be a 0. And we can swap this circuit here, or what the circuit does here. We change that to a 1, and now everything is shifting to the left. This is the most significant bit, and this is the least significant bit, so that's why this is shift left, and the other one was shift right. And it does the same thing. It shifts each one to the left, drops this bit here off into the shift out, and the 0 is what replaces our A0. And so just the inner workings of what this looks like. We're using muxes here to make this decision. Basically, it says, okay, and we can look at A3 here and compare that to the rest of the problem. So say that we're just looking at A3. Connects to this mux here and this mux here. So say that we want to shift to the right, which is what this automatically does here. Well, our A3 will connect to this mux, connects to the 0 because that's what shift right is, and it connects to the 0 of Q2, and this is A3. So we connect it to Q2 so that when we want to shift it right, it's there at Q2. It's in the 0th slot, so that when this is 0, it's going to shift it to Q2. And when this is 1, well, it's going to put it in the shift out bit, because when it's 1, you're shifting left, and it's going to shift out of the problem. And then say that we had a 1 here, this one will go to Q1, and then Q0 will always return 0. So that's kind of the inner workings. It utilizes muxes to get this job done. And then we can go into, this is another version of the shifter, but this time we have 4 different options. We can either shift left, have no change, shift to the right logical, or shift to the right arithmetic. And those are two different forms of shifting right. And so 0, 0 signifies shift left. And so say that we have 1, 1, 1, 1. It's going to shift left. This one here. So S0 being 1 and S1 being 0, that signifies no change. This will signify a shift right logical. And what this does is that it shifts everything to the right 2, and it always has the fill bit be 0. So it'll take A3 and A2. It'll make them A1 and A0 respectively. And then A2 and A3 will always be 0 in this particular case. So it doesn't, these bits actually don't matter at all. They don't affect the circuit in any way. And then lastly, this is arithmetic shift to the right. What this does is that it shifts everything to the right over by 1. And then it makes that fill bit whatever the original most significant bit was. So if A3 was 1, it's going to shift over my A3 to Q2, and then it's going to make that Q3 whatever this is. If you notice, they're always the same. And this one will always be the shift out. That will always change that. That will always change that. Oh, and then that's obviously the switch. So, and then I'll show you the inner workings of that. It's a mess, but basically it's just a more complicated version of what we did in the beginning. It's actually the exact same thing, except this time we just have 4 options. And so you saw what we did in the beginning to make everything shift left, so I won't explain that. But for no change, all we're doing is we just connect, and no change is signified by this here. Yeah, by 0, 1, or 1, 0, you could say. Okay, we'll call it 0, 1. We'll start with this one on the top. So 0, 1. It's signified by 0, 1. And what this does is that all we're doing is that, well, A0, and this is signified by slot 1 and all these muxes here. It just connects right in. A1 will connect right to Q1, A2 will connect right to Q2, and so on. And so it'll do nothing, which is exactly what we want. For the shift right logical, which is 1, 0, what this does is it'll take this A3, and it connects it to to Q1, and it goes in the 2 slot, because this is our technically our, second or third, you could say, because we have 0 here. This is our third operation. It'll connect into the 3rd slot. And so it'll go in that 2 slot there, and so A3 will become Q1, shifts it over twice. A2 will go into, let's see, it'll go into Q0 in slot 2. So that'll shift over. A0 will, let's see, that'll fall off. So for the shift out bit on this particular circuit or version of the circuit, you could say, I left the shift out as 0 always because we have 2 bits that are actually getting shifted out. And so they could be 1, 1 or 0, 0 or whatever. They could be a certain combination of a bunch of different of numbers. And so, well, this is only 0 or 1. It can't represent 2 bits. So I just left it as null, basically. Low will represent null in this case. And for functionality purposes, it actually doesn't matter. So, and then, yeah, lastly, we can talk about the arithmetic one. This just shifts everything over 1, just like in the original shifter, except this one, instead of making our Q3 equal to 0 always, we're just making it equal to what A3 is always. So yeah, that's the difference. And so I have this question here. It's, what is the difference between logical and arithmetic shifts? Well, as sort of previously explained, a logical shift will shift everything to the right 2. And then the replacement bits will always be 0. And then a arithmetic shift will always shift over 1 and will make that most significant bit what the original most significant bit was. So yeah. Muxes are useful building blocks for these shifters because because they allow us to create circuits that can shift in a bunch of different ways. If we just wanted to output something that only shifted to the right or to the left, we wouldn't need muxes. But this allows us to create dynamic circuits that can give us a bunch of different representations of the same input. And that's pretty much it. So thank you for watching. Thanks for checking out my website. We'll see you in the next one.